a single relay chain block can contain the data from many different parachains. Now we have all the tools and information needed to properly start checking them. And this process is called approval checking, and is where the actual execution sharding happens. Instead of having all the parachains validated by all of the validators, we use verifiable random functions, VRFs, to blindly assign a small subset of validators to do the checks for each parachain. It is a minor simplification, but generally around 30 validators are selected to do the checks for each of the parachains. If all of them successfully validate the data, and no one raises an alarm, the collation is considered valid. But what happens if something goes wrong? If a validator spots an issue with the data submitted by a parachain, they can raise an alarm and trigger an escalation, a dispute about the correctness of the data. This will be seen as a call to action, so instead of the usual small subset of validators doing the checking, it will cause all of the validators to start checking. All the validators checking and casting their votes, either that the data is valid or invalid, means that if we look at the majority, we'll always get the right answer. Remember that we assume that 2/3 are honest. It is an expensive way of validation, but it is the only one that is truly definitive. So it is a necessity when there is something suspicious. After the winner of the dispute is decided, the losing side gets penalized, their validator stake slashed, and the winning side collects a bounty. Notice that all that needs to happen to catch a malicious collation is for there to be one honest validator out of the randomly selected 30. This single honest validator can then escalate the issue into a dispute and focus everyone's attention on it, effectively preventing the malicious data from progressing further. But what are the chances of all the 30 selected validators being malicious? The actual chances are extremely minimal. There is only around a 1 in 206 trillion chance of this happening. That is to say, it is not realistic for it to happen, especially when we consider that every failed attempt comes with hefty penalties, so attackers will sooner go bankrupt than succeed.